Welcome students. So in this session we are going to study the serial communication interface 8251. In last session we were studied parallel communication interface, that is 8255. Okay, so first of all we must know what is serial communication, what is parallel communication. First we are consider parallel. So consider the railway track. So the two bar are present in parallel format. Okay, that is uh, placed some distance with each other. Okay, then that is a parallel. The railway track is parallel. Okay, right. Similarly, consider the decorative lights, the LED lights. So the LED lights, the LEDs, each LEDs are connected in serial manner. Okay, so every LED can glow at 3 volt, but group of LEDs connected in serial manner, so we can give 230 volts. Okay, with some current limiting resistor. So that is a serial lights. So when we are saying these things, the parallel needs separate line, the serial needs common lines. That is a basic thing. Okay, right. So parallel communication needs separate line. If you are having 5 different lines, means we need 5 different wires. That is a parallel. If it is serial communication, means if that is single line is enough to transfer the data between one sender to receiver. Okay, so we can say some example related to parallel communications. So I think you have a knowledge about dot matrix printer. So the dot matrix printer is parallel port, that is connected with the computer by using parallel port. But nowadays most of the CPU not having parallel port, because nowadays we are not using parallel port, because the parallel port wires are very heavy. Number of lines are more than 25 or 50. Okay, then cost wise we can see that is the wire cost is very high. Okay, then it is mechanically very weak. So many problems are present. If the wire length is very suppose if the wire length is increases, then that increase the cost of the wire. So because every line needs separate wire, that is a parallel. Okay, right. So if any one line is missed or disconnected, it will affect the entire communication. Okay, so these are the so many problems present in parallel communication. See, this is a parallel communication, this is a sender, this is a receiver. Here we are having a 8 bit, so we need separate 8 lines. Okay, that is a parallel communication. See, this diagram indicates a 3-bit transfer. So actually here we are having a separate path for data transfer. Okay, this is a parallel. If any one of the wire is disconnected, the entire data transfer is lost. Okay, this is a parallel communication. Then another one example, we can say that the old CPU that has a parallel communication between motherboard and hard disk, motherboard and DVD drive. Okay, so the parallel wires are looking like a ribbon. Okay, very wide wires along with a jacket that is connected with the motherboard. Okay, so this is very difficult to maintain. Suppose any one wire is lost its connection, then the entire system will affect. Okay, and the second one is a serial communication or serial transfer. So sender and receiver communicated by a single wire. Okay, with reference wire. Okay, right. So this is a serial communication. The data are transferred one by one, the bits are transferred one by one, but in high speed. When compared to these two, this transfer is very easy and cost effective. Serial transfer needs 2 or 3 wires. Okay, maximum it needs 4 wires. So if you are using a very long communication, when compared to parallel communication, the serial communication cost is very less. Okay, then we can transfer the data in high speed. Okay, right, and the error correction also very easy in serial transfer. Okay, so in this session we are going to study the serial communication interface with 8086 microprocessor. Okay, and when we are seeing the serial communication, we can see different examples. Consider our pen drive. Pen drive communicated with CPU by using 4 lines: one ground, one VCC, one TX, one RX. Transfer, receiver, VCC and ground. Only 4 lines are used in pen drive. So it is a high speed data transfer. Similarly, nowadays the CPU and the motherboard, CPU and CD drive is connected by using SATA cable, SATA cable. That is also one of the serial port. So very smaller cable. Okay, right. Pen drive is also very smaller cable. Similarly, our phone and computer is connected by the data cable. Data cable also having 4 lines: ground, VCC, TX, RX. That means transfer, receiver. So the 4 lines are used to transfer the data between one device and another device. That is called as serial transfer. Okay, so let us enter into video. Right, so this is a flip-flops. By using the flip-flop, we can consider the serial transfer and the parallel transfer. See, this is the first one, the serial transfer. Here the output is single line output. The inputs are 4 lines. Here see, the outputs are 4 lines. That is a parallel output. Okay, so these are the parallel output. This is a serial output in the single line. So this is the example of serial transfer and parallel transfer by using flip-flop. Okay, right. Then the recap. In the last class we have studied about parallel communication interface or programmable peripheral interface, right? So that is a 8255. Okay, 8255 is mainly used to connect the parallel device with microprocessor. Okay, 8255. The IC number is very important. Most of the question is asked by the IC number only. Okay, right. Otherwise it will ask like this, the parallel communication interface, programmable peripheral interface, like that. Okay, so that is a 8255 we were studying in the last session. So today we are going to see 8251, that is serial communication interface. Okay, so on completion of this session you would know about serial communication interface, that is 8251. Okay, let us see.
u.com.
So this is a IC diagram of 8251, that is manufactured by the Intel. Okay, so it is serial communication interface, Intel 8251 USART. What is USART? Are you heard about that? Let us see. USART means Universal Synchronous Asynchronous Receiver Transmitter. What is universal? Universal means what? Universal means it is common to common device. The 8251 can be used in any device, any microprocessor or any microcontroller to transfer the data in serial manner. Then synchronous. What is synchronous? Synchronous in the sense the transmitter frequency and the receiver frequency both are same, that is a synchronous. Okay, synchronous means same frequency. Two devices operated in same frequency means that is a synchronous. Asynchronous means the two devices operated in different frequency, that is called asynchronous. Okay, receiver transmitter, it is act as a receiver, it is act as a transmitter. So this device 8251 is universal synchronous asynchronous receiver transmitter. Okay, so that it is also called as USART, Universal Synchronous Asynchronous Receiver Transmitter, USART. Okay, right. So this is a programmable chip, so we can program this IC as per our need. Okay, designed for synchronous and asynchronous serial data transmission. So this IC is mainly used to designed for synchronous and asynchronous serial data transmission. So the physical size is 28-pin dual in package, 28 pins. It has the 28 terminals. Okay, dual in package. The package is dual in package. What is dual in package? So it is a dual means in both sides we are having the pins, the terminals. So this is one side, and this side also we are having the terminals, but in this photo it is not shown. So both side we are having the terminal, so that it is dual in package. So this 8251 converts the parallel data into serial stream. So why it needs to convert parallel to serial? Because it is connected between the microprocessor and other device. Suppose the microprocessor is having parallel lines, so the data lines and address lines, everything is in parallel. So microprocessor, for example, if you are consider 8086 microprocessor, it has 16 data lines. The 16 data lines are separate lines, that is a parallel. So if you connect the microprocessor at 8251, so microprocessor parallel lines is connected with the 8251 lines. That means the parallel data are converted into serial data. Okay, so it convert the parallel data into serial streams of bits suitable for serial transmission. Okay, so it receives the data from microprocessor in parallel form, and the parallel data is converted into serial data. Then the serial data is transmitted to the next device. Okay, right. Then same way it receives serial streams of bits. So if it is act as a receiver, it receives the serial data from external device, and it is sent to microprocessor in the form of parallel. So it converts serial data into parallel and it transfer to the microprocessor. Okay, so it is act as a receiver and a transmitter between microprocessor and other device. If it is act as a transmitter, then it convert parallel data into serial data. If it is act as a receiver, it converts serial data into parallel data. Okay, right. So it is act as a bridge between microprocessor and external device. Okay, so and it is also synchronous and asynchronous. For example, microprocessor is executed in one frequency, or example is operated in 6 megahertz, then external device is operated in 2 megahertz. Then this USART match the data transfer between the two device, and it is collect the data from external device, and it is sent to microprocessor in different speed. So the transmitter and the receiver is operated in different speed, that is called asynchronous. Okay, if it is both the device or a microprocessor and external device both are at the same speed, then that is called synchronous. Okay, same frequency, that is called synchronous. Okay, right. Then this is a physical structure of 8251, the pin diagram of 8251. Okay, so here this is a standard pin diagram. So it's having the 28 pin and 14 pin in one side, another 14 pin in another side. Okay, this is a signal diagram 8251A. Actually both are 8251A. This is a pin diagram, this is a signal diagram. So if you no need to draw pin diagram in examination, only you have to draw the signal diagram. This is a signal diagram. So the signal diagram indicates what are the signals present in a 8251. See, this is D0 to D7 is a parallel input, that is 8-bit parallel data receiver. So microprocessor data lines are connected with this D0 to D7 lines. Actually here is having the lines are spreaded over the entire IC, that is a D2, D3, D4, D5, D6, D7, then D0, D1. Okay, so that is combined together here. Then another one pin is reset. So this pin is input pin that is coming from microprocessor to reset this 8251. Then this is a clock. The clock is a clock signal that is coming from the microprocessor. And C by D, what is C by D? Here is the, that is a C by D means control register or data buffer select. So if you perform the read write operations, so at the time which area we have to read or write. So two things are there, one is a control word register and another is a data buffer. Data buffer is to receive the data, control word register is to program this 8251. Okay, then read or D, that is to give the read signal. WR means give the write signal. CS means chip select. So if this pin is enabled, then this IC is selected. If it is, this pin is disabled, the IC is disabled. Then USR, what is USR? Actually here where is it is, that is USR, sorry, DSR is present here, that is a data set ready. DTR mean data terminal ready. These are some control signal that is used to give the signal, green signal to data transfer. If the device is ready, then it will produce the data. Then CTS, clear to send data. Clear to CTS means clear to send data. That means, so before send the data, you have to clear the old data, that is done by this pin. Then RTS, receive to send data, request to send data, sorry, request to send data. So RTS means request, that is these are the control signals that is used to transfer and receive the data before it before transmitting and receiving the data. So we are enabling these two things. Okay, the next one is TXT. This is a pin we are using in pen drive. TXT and RXT. What is that? TXT means transmitter data, RXT means that is a receiver data. Okay, RXT means receiver data. So the data lines. Then TXMT means transmitter buffer empty. Where is it is transmitter empty. TXMT means transmitter empty. TXC means, where is the TXC, transmitter clock. So if it is operated in asynchronous, then we are using this pins TXC, then the transmitter is in one clock, and RXC, that is a receiver clock. RXC, that is here one, that is a receiver clock, that is in another one clock, that is coming from receiver, this is coming from transmitter. Okay, right. So these two clocks are different in asynchronous mode. If it is synchronous, the two clocks are same. Then VCC is a supply voltage, 5 volt is supplied here, this is a ground. Okay, then RXT is already, that is a receive data, then RX ready, so receive ready. Okay, then here is the last pin is signal, that is SYNDT, synchronous detect. Okay, then break detect, synchronous detect, break detect, and these two are used to control the IC whether it is operated in synchronous or not. Okay, so these are the signals used in 8251. So if the question asked like this, that is explain the signals of 8251, means you have to draw this diagram, and explain these signals. Okay, right. Next you want to see the block diagram of 8251. Actually, what is block diagram? The block diagram indicates what are the part inside the 8251 IC. Okay, actually these two blocks are common to all the ICs. Okay, all the interfacing ICs, these two blocks, that is a data bus buffer, read write control logic. Okay, these two buffer are common to, sorry, the two blocks are common to all the ICs. Okay, right. First we will see one by one. First one, we are going to see the data bus buffer. Data bus buffer that is connected with 8086 the microprocessor data lines. So this is a D0 to D7 the data lines. It's a 8-bit data bus buffer. This buffer is to store the data to be transmit or the data to be received. Okay, so it is a temporary buffer. It can store 8-bit data at the time. The buffer is connected with internal data bus of 8251. Then next one is a read write control logic. This read write control logic control the entire block based on the control signal received from 8086 microprocessor. So these are the control signal coming from the 8086 microprocessor. According to the control signal, this block control the entire remaining blocks of 8251. Then this is a these two plugs are common to all the ICs. Then this is a modem control. What is modem? Modulator and demodulator. So in our home we are using the modem, okay, geo modem or landline modem, etc. So these modems are mainly used for internet communication. So modem means that is a modulator demodulator. Okay, so it is act as a transmitter and a receiver. Okay, right. In the modem we are using these control signal DSR, DTR, transmit ready data, data send ready, data transmit ready, then CTS, clear to send, and receive to send, like that. Okay, request to send, clear to send. Okay, these are the signals used in modem controller. The modem control connected with the internal data bus, and also it is controlled by the read write control logic. Okay, and the right side we are having the output blocks, that is a transmit buffer. So these are used for transmitter, these two blocks are used for receiver. So the transmit control having transmit ready, transmit empty, transmitter clock. Okay, these are the transmit control. This block control the transmit buffer. Okay, according to the control signal received from microprocessor through read write control logic and other external device. Okay, so this transmitter control also control the external device connected with 8251 by using transmit ready, transmit empty, and transmit clock. Okay, right. The transmit buffer that is used to handle the data between external device and 8251. So it is a 8-bit buffer. So it convert parallel data into serial data, that is a transmitter. So the data are received from data bus buffer in parallel, and it is convert the parallel data into serial form. So the data are connected with this internal data bus. So that data bus connected with the transmit buffer. The transmit buffer convert parallel data into serial data, and it is transferred to other device in serial format. Okay, this is a transmitter side. So this device transmit the data in serial format. Then here this is a receive RxD, that is a receiver data. It receive data by using receiver buffer. This receiver buffer convert serial data into parallel. Actually data are received in the form of serial. Okay, but microprocessor can understand only parallel data. So this received serial data is converted into parallel data. Then the parallel data is given to data bus buffer through the internal data bus, and the data bus buffer give the data to microprocessor in parallel form. So the microprocessor receive the data in parallel, and it is send the data in parallel, but the parallel data is converted to serial form when the microprocessor transmit the data. The serial data is converted into parallel data when microprocessor receive the data. The receive buffer is controlled by receive control. The receive control is again controlled by read write control logic, that is the control signals coming from 8086 microprocessor. The receive control control the other device, that is by using receive ready and request receive data, and synchronous break detect, synchronous detect, and break detect. Okay, so this is a receive control. Okay, right. So this is a explanation of entire block diagram. The block diagram is very important. You have to draw very neat manner in university examination. Okay, next we are going to see the section inside the block diagram. First one is read write control logic. So interface with the microprocessor unit, determine the function according to the control word, monitor the data flow. This is the read write control logic operations. Transmitter means when the 8051 act as a transmitter means it converts the parallel word received from microprocessor unit into serial bits. Transmit serial bits over TXT line to the peripheral device. Receiver means it receives the serial bits from peripheral device and convert the serial bits into parallel words. Okay, then it transfer parallel word to microprocessor unit. Okay, then data bus buffer is a 8-bit bidirectional buffer. Okay, modem controller that is used to establish data communication modem over telephone line. Okay, so modem controller mainly used for data communication, that means internet purpose, so that is communicated with the telephone line. So that if you are using our telephone line in our computer, so we are using this modem controller. Okay, in 8251. Then input signals. First one, the chip select CS bar. When this pin is goes low, the 8251 is selected by the microprocessor unit for communication. Otherwise, the 8251 is disabled or in switch off condition. Then C by D, that is control word or data. Control or data, when this signal is high, it indicates that's a control word register or status register is considered to read or write. When this signal is low, the data bus buffer is addressed. Okay, control and status register is differentiated by read and write signals respectively. Okay, right, so this is the second signal. And next one is a write signal. The write, the control register or send the output to the data buffer by using write pin. Read is read pin, either read status from status register or accept the data from data buffer. This is connected to either IO or memory read, IO read or memory read. Then reset pin is used to reset the 8251, so it completely clear all the registers and data buffer. Okay, so it is reset the 8251. Then CL key means clock, it is connected to system clock necessary for communication with microprocessor. So these are some table that is used to control the entire system according to the four signals CS, C by D, then read and write. Okay, so this is a basic method. If CS is 1 means, if CS is 1, then the 8251 is not selected, that means that the your ART is not selected, that means it is off condition. Okay, so here 0110 means microprocessor unit write instruction in the control register. Now the control register is selected, then it perform the write operation because the read operation is disabled. The read operation is disabled by logic 1. Then if 0101 means microprocessor unit read the status from status register, so it perform the read operation. Then 0010 means microprocessor unit output the data to data buffer, it outputs the data to data buffer. Then 0001 means microprocessor unit accept the data from data bus buffer, it is receive the data. Then A1 and XXX means if it is 1 means the IC is disabled, so no operation is can be handled. Okay, right, this is a functions. Then control register, the register can be accessed an output port when the C by D pin is high. So this register is accessed when C by D pin is high. Status register check the ready state of peripheral. Then data buffer is a bidirectional 8-bit, it can handle the data. Okay, then transmitter section, the transmitter section accept the parallel data and convert it into serial data. Okay, so the transmitter means the 8251 is act as a transmitter. So who is transmit the data? Microprocessor is transmit the data to peripheral device through 8251. So microprocessor give the data in parallel format to 8251. 8251 accept the parallel data and convert the parallel data into serial data. After that, it will transmit the serial data to peripheral device. So to act as a transmitter, it needs two register. One is a buffer register and another one is a output register. The buffer register is used to hold the 8 bits that is coming from a microprocessor unit. Output register convert the 8 bit into stream of serial bits. Okay, then the serial bit is transmitted over the single line. Okay, the transmit data on txt pin with appropriate framing bits, start bit and stop bit, because serial data transfer is only by a frame. So each frame contain some data bits, then start bit, stop bit, parity bit, etc. Okay, right. Then signal associated with the transmitter section. Inside transmitter section, the following signals are considered. First one is a TXD, transmit data. So serial bits are transmitted on this line. Then TXC, transmit clock, control the rate at which bits are transmitted. The transmitter clock control the transmitter bit rate, how many bits are transmitted per second, that is considered by TXC. Then TX ready, transmitter ready. So it can be used to either interrupt the microprocessor unit or indicate the status. Okay, then TXE, it's a transmitter empty. So logic 1 on this line indicate that the output register is empty, then we can transmit. If it is 0 means the output register is full, so we cannot transmit. If the output register is full, we cannot transmit because the data are lost. Okay, next one is the receiver section. The receiver section accept the serial data from peripheral device and it convert the serial data into parallel data, and the parallel data is sent to microprocessor unit through the data bus, okay, data buffer. So this section consists two register, input register and buffer register. So okay, the input register receive the data from peripheral and it's convert into parallel format. The buffer register transfer the data to microprocessor unit in the form of parallel. Okay, signal associated with the receiver sections are the three signals. One is a RxD, that is a received data. So bits are received seriously on this line and converted into a parallel byte into receiver input. So the RxD is a receiver data receive signal, that is receive the data in serial manner and is convert the serial data into parallel. RxC means receiver clock. So the receiver clock that is used to control the received data rate. Okay, receiving bit rate, how many bits per second is received. Okay, then Rx ready, receiver ready, it goes high when the USERT has a character in the buffer register and it's ready to transfer it to microprocessor unit. So if it is 0 means it is not ready to transfer the data to microprocessor unit. Okay, then signal associated with a modem controller. Modem means modulator, demodulator. So that is used to handle the data. Okay, so DS or data set ready means normally used to check if the data set is ready when they communicating with modem. If it is not ready, we cannot communicate with modem. DT or data terminal ready means the device is ready to accept the data when 8251 is communicating with the modem. The device is ready to accept the data means at the time the data terminal ready is enabled high, that is enabled to high. RTS means request to send data, the receiver is ready to receive the data byte from modem. Okay, so last one is CTS, that is a clear to send, clear the buffer register to send the data. Then control words, there are two type of control words are used in 8251. One is a mode instruction and another one is a command. So mode instruction, that is used to setting of functions, that means setting of modes, and for command is used to set the operations. Okay, let us see. First one, mode instruction. The mode instruction is used setting the functions of 8251. Mode instruction will be in wait for write at either internal reset or external reset. That is the writing of control word after resetting will be recognized as a mode instruction. Items set by mode instruction as follows. First one is asynchronous and asynchronous mode, stop bit length asynchronous mode, character length, okay, then parity bit, baud rate factor. So these items are set by mode instruction. Okay, so whether the device is operated in synchronous or asynchronous mode. Synchronous mode means the transmitter and receiver used in the same frequency. Asynchronous means the transmitter and receiver is operated in different frequency. Stop bit length. In asynchronous mode, the transmitter and receiver is operating in different frequency. So how many stop bits are needed, that is indicated by this mode instruction. And then character length, how many characters are we are transmit per frame. Then parity bit, so parity bit and baud rate factor, these are considered in mode instruction. And the internal synchronization, that is in synchronous mode means internal and external synchronization is considered. The number of synchronous characters are considered in synchronous mode. Okay, the bit configuration of mode instruction is should fear 23. In this case, the synchronous mode is necessary to write 1 or 2 byte synchronous character. If the synchronous character were written, the function will be set because the writing of synchronous character constitute the part of mode instruction. Okay, this is a bit configurations of status word. Okay, right. So this 8-bit consider the different status of 8251 serial transmitter. First one, the TX ready, transmit ready. So this when is 1 means the parity different from TX ready terminal, refer to explanation of TX ready terminal. Okay, so already we are studied in transmit ready. Okay, if it is 1 means the device is ready to transmit. Okay, right. Then RX ready, same as terminal, refer the explanation of terminals. Okay, RX ready, then transmitter empty, then synchronous detect, break detect. These signals are already we have studied in previous slides. Okay, after that PE means in PE, that is a PE indicate parity error. So parity error means the error is present in even parity, odd parity. What is even parity, what is odd parity? Consider one frame, the frame consists of data bytes. After that start bits, stop bit and parity bits. So the parity bits indicate number of ones. Okay, how many number of ones present in a data, even number of ones or odd number of ones. Okay, suppose the even number of ones present in a data means that is a even parity. Odd number of one present in a data means that is considered as odd parity. So the even parity is indicated by 1, odd parity is indicated by 0. So suppose this 1 and zeros are collapsed, that indicates parity error. Then overrun error, the overrun error that will the data are overrun, that means the data are overlapped. Okay, the data are lost at the time the overrun error is enabled. Then framing error, so the data are transmitted in the form of frames one by one. So if the frames are missed or lost, then it consider the framing error. And the last one is DSR, it shows that DSR data set ready. Okay, so if it is 1 means the DSR means 0 means it is enabled, if it is 1 means that is a disabled. Okay, so these are the 8-bit status of 8251. Then the command, second one is a command. The command is used for setting the operation of 8251. It is possible to write command whenever necessary after writing a mode instruction and synchronous character. The command is right after writing mode instructions. The items to be set by the command are follows. What are the items are we are considered in command word is, first one, transmit enable or disable, receive enable or disable, transmit ready, receive DTR, then request to send uh, data, transmit ready, or request to send output data, then resetting of error flag, sending to break characters, internal resetting, hunt mode, that is a synchronous mode. These are considered in command. So this is a interfacing of 825i with 8085 microprocessor. Actually, we are not studied the 8085 microprocessor. 8085 is a 8-bit microprocessor, so that is a previous version of 8086. Okay, so here this is a 8285 is connected. So this is a chip select logic by using a decoder is considered. Okay, so actually this is not needed, right? This is also not needed. Then programming of 8251, the 8251 programming. Okay, so how to program 8251, that is by using, first one is a mode register. So this mode register indicate the different modes of 8251. Okay, right? So first two bits are used for baud rate control, second two bits are used for character length, and the fourth bit is used for parity, fifth bit is used for also parity. This is a parity indication, this is a parity enable. Then last two bits used for number of stop bits. Okay, so based on this we can program the mode register. So first two bits are assigned by baud rate. What is baud rate? So baud rate means how many bits transferred per second. Okay, so in communication mode, in COM port, baud rate is considered how many bits transfer per second, that is a baud rate. Okay, so here 00 means that is a synchronous mode. Okay, if it is 01 means, so clock into 1. Okay, the speed of data transfer is based on the clock. Okay, 10 means into 16, 11 means into 64 clock. Okay, right? So this is a baud rate generation. Then character length, how many bits we are going to transfer. Okay, so character length is considered by 2 bits. 00 means the character length is 5 bits per frame. 01 means 6 bits, 10 means 7 bit, 11 means 8 bit. Mostly we are selecting 11 because we are transmitting 8 bits per second by 8 bits per frame. Next one is the fourth one is the parity enabled. If it is 0 means the parity is disabled, 1 means parity is enabled. If parity is enabled, it considered two things, that is a odd parity and even parity. Parity means number of ones present in character. If 4 number of ones present means that is a even parity, that is set to 1. It is 5 number of ones present in, that is odd parity, that is set to 0. This pin set to 0. And last two bits assigned for number of stop bits. How many stop bits are needed? Actually in a frame we are consider start bit, stop bit, parity bit, etc. So stop bits, how many stop bits? Actually the stop bits are, maximum stop bits is 2 bits, minimum is 1 bit. Okay, actually 3 levels of stop bits are considered. If it is 00 means stop bits is invalid. 01 means 1 bit is considered. 10 means 1.5 bits are considered. 11 means 2 bits are considered. Okay, so this is a number of stop bits used in the frame during data transfer. Okay, so this is a thing, very important thing. So based on this we can create one 8-bit number. That 8-bit number is loaded into mode register. So according to that number, the 8251 is operated. Okay, next one is a command register. Command register is used to command the 8251 by using zeros and ones. First one is TXE. If TXE is 1 means transmit enable, if it is 0 means transmit disable. Second one is a TTR. So data terminal ready. If it is 1 means data terminal ready is disabled. If it is 0 means the DTR, it is active low. If it is 0 means the data terminal ready is enabled. Then RXC, receiver enabled. If it is 1 means the it can receive the data. If it is 0 means it is disabled. Then send break character SP or K. If it is 1 means it will send the break character. If it is 0 means it don't send the break character. Okay. In when will it is enabled? TXD pin is low. When TXD pin is low, at the time it will do. Then ER means error reset. If it is 1 means the error is resetted. If it is 0 means the error is not resetted. When RTS, request to send. Okay, so when will it is working? CTS pin is low at the time, or the CTS is enabled at the time the request to send is considered. If it is 1 means it is request to send is enabled. If it is 0 means it is disabled. The next one is the internal reset, IR. The IR is to reset the internal that is internal registers. So if it is 1 means it is reset the internal registers. If it is 0 means it is not reset. Then last one is a EH, enter hunt mode. So if it is 1 means it is enable the hunt mode. It means enabling the search for synchronous character. Okay. If it is 0 means it is a disable a hunt mode. Okay. So this is a commands used in command register of 8251. The next one is a status register. Already we have studied this one. So status register, that is indicate the status of 8251. So the first bit is used for transmit ready. Okay, TX ready, transmit ready. If it is 1 means it is ready to transmit. If it is 0 means it is not ready to transmit. Similarly, RX ready. It is 1 means it is ready to receive. If it is 0 means it is not ready to receive. Then transmit empty. So transmit empty. If it is 1 means the transmitter buffer is empty. If it is 0 means the transmitter buffer is not empty, that is having data. Okay, so parity error P, if the P equal to 1, that having the parity error. If it is 0 means no parity error is present. Then OE, if it is 1 means overrun error is present. If it is 0 means the error is not present. Similarly, framing error, if it is 1 means framing error is present, 0 means framing error is not present. Then synchronous character is detected. If it is 1 means synchronous character is detected. If it is 0 means it is not detected. Then if it is last one, DSR, data set is ready. If it is 1 means the data set is ready. If it is 0 means data is set is not ready. Okay, right? So these are bits are used to indicate the internal status of 8251, that is a status register. Okay, so it indicates the status. Okay, right? So this is the 8251 interface with 8085. This based on the diagram, the 8251 is interface with 8285. So the 8251 is connected with the MAX 232. MAX 232 is a serial port driver IC. This IC receive the data from external device. Actually, see, this is a 4 lines: TXT, RXT, transmit data, receive data, RTS and CTS, clear to send, request to send. These 4 lines are used to data transfer in serial manner. Okay, right? So actually this is a COM port. What is COM port? Do you know COM port? So behind your CPU we are having the COM port near to VGA port. Okay, so by using the COM port we can interface microprocessor and microcontroller with computer. Okay, right? This is a interfacing. Okay, right? So this so by this session, now you can understood the 8251 block diagram and its explanation, and the modes and control word registers, 3 control word registers. Okay, right? So the questions are asked in university exam as explain USART. Okay, universal synchronous asynchronous receiver transmitter. Then explain the block diagram of 8251. Okay, then explain the block diagram of serial communication interface. So these three ways they will ask the questions. Okay, 8251 serial communication interface, universal synchronous asynchronous receiver transmitter. Okay, right? So this way they will ask the questions. Okay students, thanks for watching. So I hope you understood the 8251. Okay, so thank you so much.